협력기회 모색에 대해 강연해 주시겠습니다. 큰 박수로 맞이해 주시기 바랍니다.
Hello, good morning. Sorry for my voice. I have some problems last week, and I will try to speak a little bit slow, just to have clear message. And okay. First of all, thank you for all of you to be here. Thank you for our organization for inviting us to come here. We are Concentrate. We are a Spanish company that allow all type of companies, all type of business to enter the quantum world. Okay, we are going to speak about a lot of different things that all business have. Problems relating to integration, to quantum readiness, to how can we start using quantum in our company, and we will provide different examples of different companies that are using quantum in different ways, and it will be very helpful for all of you to start thinking about how to enter this world. Well, who and what is Concentrate? We are a quantum as a service platform, probably the best quantum as a service platform in Europe. I don't know if in the whole world, because I didn't have the opportunity to test everything, but I'm sure that we are the best quantum as a service platform in Europe. You can see here that the quantum world is really complex. It's really complex, but we all the founders of Concentrate came from very big business company, like a financial company, defense, logistic, consultancy service. So we know all the needs that a company have. For example, all the problems that you can find in papers are not real use cases, are academic benchmarking use cases, but are not real. You need to translate your real problem into something related to quantum algorithm. Then you need to build. You need to build your quantum algorithm and test. You need to compare. You need to compare with using different quantum techniques and using different quantum hardware, not only one, because there is no clear champion. We can see later. And you need to do this cycle a lot of times until you have a clear solution. And of course, I have the solution and I need to deploy. I need to put in the selected way in my business workflow. And after that, we need to continue experimenting with new techniques, new hardware, new error mitigation companies, whatever you need. So we are the platform that solves all the business-related problems using quantum. This is Concentrate. We are a trusted quantum partner. We have a lot of clients. Most of them are international clients. For example, Moody's Analytics, our flagship client, IBM, Amazon, and a lot of companies all over the world. And all the clients says that Concentrate helped them to enter this quantum world, to start selecting the most promising use cases, to start selecting the most promising quantum techniques to solve those use cases, letting them to choose which quantum hardware could be the best to solve all this combination of use case and algorithm, and after that to give this solution to the IT team and integrate in the business workflow, and all inside the same product. We are also partnered in a different consortia. For example, the World Economic Forum. We are part of the Open Quantum Institute, created by the CERN Institute in Switzerland. We are part of the European Quantum Initiatives. We are part of a lot of different associations all over the world. Okay, why? Because we understand the language of business people and technical people, and we could translate the message from one side to the other. And this is very important because there is a huge gap in the quantum world between academia and business. Academia are building quantum hardware, perfect. They are building quantum algorithms, perfect. They are researching new techniques of developing things that work with quantum, perfect. But business needs solutions. And we translate those messages. Before talking about all the solutions that we provide, first we could start talking about the common issues that a company has when entering the quantum world. First of all, this is real. There is a real quantum complexity. First, there is a huge misunderstanding of what quantum could do. When you enter a company and start talking with them, most of them said, okay, it's something that could change big data problems. No, it's not quantum. It's related to, I could have a quantum computer inside my phone. No, it's not that. There is a huge misunderstanding. But there is another problem. When they understand what quantum could do, they face another problem. That is, okay, I need to start building something, but how can I start? A lot of companies that are building quantum solutions start building POCs. POCs is just a piece of code with a presentation, and for a company it's no sense to have that, because okay, the proof of concept works, and now what happened with this piece of code? We need to industrialize in somewhere. But what happens if this POC doesn't work? You need to start signing another agreement with another quantum hardware provider just to test if the POC works or not. It's probably a nightmare for a lot of companies to start exploring this classical workflow of improving your workflows. There is another problem. I don't know if the POC works or not. I need to compare. I need to compare with my classical solution, for example, a financial optimization algorithm. I need to compare with my POC, with my quantum algorithm. And I need to build different quantum algorithms because I don't know in advance if this solution could be better or not. I could have some guess, of course. I could have some guess of if I need to use amplitude estimation, we need variation algorithms or quantum annealing. Okay, but you need to build, you need to test, and you need to run your algorithms with different quantum hardware. And this costs a lot of money because you need to sign agreement with a lot of quantum providers. and you need to pass a lot of different departments inside your company until you have the opportunity to test your quantum algorithm in some 3, 4, 5, 10 quantum hardware. And then you need to dismiss all the solutions except one, or all of them. And what happened? This is a lot of time-consuming process for a company. Some of the companies that are clients of us told us that they have like a 2-year roadmap just to test one proof of concept, because all the papers that they have to do a lot of papers with compliance, with data, with IT teams. They have a lot of things to do. And it's 2 years or one year and a half. And this is, most of them, we have partners, are partners of us, most of them. But you need to test in almost everyone. You need to test in almost everyone. And you need a platform that is the way to start using all of them in a very easy way. Of course, you need to test. If you want to have superconducting top atoms, if you need to have, and you need to test all the use cases with all the combinations, because for one use cases you could prefer type ions. For another, you need to test with digital annealing or analog annealing or photonics, whatever. You need to test. There is no clear champion. Well, there is a lot of potential use cases in financial services. My colleagues have spoken about that. But this is very important. We learned a lot of AI and machine learning adoption in companies. We learned a lot. So why cannot use this roadmap of adoption from AI and machine learning and adapt to the quantum world? It's exactly the same. We need to select the use cases. We need to analyze the impact, because some use cases are very promising, but the impact in your P&L is very, very low. So you need to dismiss that use case. You need to benchmark your ideas. You need to benchmark your ideas because you need to have a clear quantum roadmap of when and where should you start. If you need to start developing this use case because it's very promising, of course, but you need to have a common criteria inside your company about what is the quantum roadmap that you want to have. And after that, after building everything, you need to integrate the winner. The winner solution you need to integrate. And this is very important for a company, because if you don't have a platform, integrating these solutions would be a nightmare for you. This is the classical adoption cycle. Okay, first you build a POC, then when you have the POC ready, you need to sign an agreement with a quantum hardware, and then you need to integrate in your workflow to test with all the different data, and then you go to data, and data say, okay, this is ready, okay, on performance, and after that, you integrate and you have the solution. But there are a lot of people deciding if this could be real or not in your company. So we learned that we need some kind of DevOps or machine learning ops to do this cycle. Okay? First, you need readiness assessment. You need to have a common paper inside your company of if your company is ready to start using quantum or not, if it's valuable for you, if how much money should you spend to do that. After that, you select 1, 2 toy use cases that could help all the people in your company to start understanding what is quantum, of course, and then you integrate, and then you scale, you optimize, but you need to come back to the first step, and you need to do everything a lot of times until you have the best solution integrating your workflow. You need to do that. It's very, very important to do a circular way, not a linear way, because quantum ends when you have the best quantum solution ever in your workflow, but it's nearly impossible to have that. Not in the classical, not in the quantum world. It's nearly impossible to you. So you need to improve every kind of step in the quantum adoption cycle. You need to do that. There are a lot of challenges, of course. There are a lot of challenges of, I put a lot of examples of data challenge, quantum hardware, integration, for example, the POC life cycle. You have a lot of challenge, and you need to face that. And you need to have a trusted partner to help to do that. And also, benchmarking is important. Why is benchmarking important? Because you go to different publications in internet, and you will see a lot of benchmarking in the quantum world, but mostly all of them are academical problems. It's not your problem. You need to benchmark your problem, not the academical problem, because the academical problem behaves different than your problem. And your problem is different than the problem of the company that is your competitor. It's different because you have different restrictions, you have different data, you have different goals, you have another problem. No, it's the same. No, it's not the same. It's different. You need to benchmark your problem. And you need to choose the best solution, balancing money, time, and impact. You need to do that. So, those are the problems, now is the solution. Concentrate is the quantum as a service platform that is leading the market in Europe, probably in other places also. And we have done that building a software as a service platform that, like other software as a service platform, that there are a lot, but also with the focus of integrating AI assistants that helps you to walk every step on your quantum journey. We have a lot of examples of doing that. Okay, first of all, you need to define your use case. Okay, we have an assistant, and we present that assistant in the in an event 3 months ago, and another one person came and gave us an example of very, very specific problem and very, very specific industry. And our assistant helped this guy to solve, to have a list of different use cases for this very, very specific industry. So we have tested our assistant with manufacturing, logistics, defense, public sector, all different sectors. And it works, and it gives you a very huge range of quantum ideas, okay? And you need to build your data. We have another agent that builds synthetic data for your use case. You need to benchmark. We are building now another agent that builds from scratch some kind of code that is capable of solving your problem with your synthetic data, with your using different quantum techniques. Not very good because it's not a real company that builds a specific quantum algorithm for your specific problem, but it's a very good starting point. So you have something, and then you need to define your experiments. What is my goal? My goal is to have fast algorithm. My goal is to reduce cost and have a cheap algorithm. My goal is to have a very good algorithm that improve my numbers, or a combination of that. Could be a combination of all of that. So this is real. This is concentric. Concentric brings brings the optimal combination of quantum algorithm and quantum hardware. We have access to more than 60 or 70 quantum computer models. I think that the second platform in the world could have access to no more than 10. We have access to 70 computers from all over the world. I put an example of one of our clients using 16 computers in parallel. We built from scratch all those layers. This is important because what we tell our clients is you need to know about quantum. What you want to know about quantum. If you don't want to know anything about quantum, don't worry. We're going to do everything for you. If you want to, I have an expert that could configure the computer. Don't worry, you can do that. We cover all those layers of the quantum program. We cover all those layers. So you need to know whatever you want. Yeah. Well, this is an example of one of our products. This is the use case portfolio management. We have a lot of different use cases, and we have public use cases. You can select different combinations of you can define your own use cases. Then you need to figure out the complexity of your problem, and you could start developing and executing all the different combinations that are capable of solving your problem. And then you need to select what is the most promising based on the results of execution. And for helping you, we have different AI models that explains to you what is the result of doing that. Okay, we have an API that is safe, that is certified. Also, we have a cost estimator agent that will tell you how much money you need to spend to have your quantum program ready. And of course, we have an IDE to start coding if you don't want to code in your laptop. And we have this tool that helps you to build your quantum journey, to what is the things that you need to do what are the most promising use cases for you, not for your industry, just for you. What are the complexity, what are the most promising combination of algorithm and hardware that could solve your problem. So, I have 1 more minute. I will speak about our flagship clients. This is the quantum ecosystem that is the most promising quantum ecosystem in the world. It's in Spain, in the north of Spain. We have now access to 16 different quantum manufacturers in this ecosystem. Only in this ecosystem, we have like 50 or 60 companies that wants to build quantum solutions. We have 20 or 30 quantum software providers. And all this thing is a collaboration ecosystem between public sector and companies. Okay, and this is our flagship client. This is Quantum for Finance Studio. This is launched by Moody's. Moody's is doing that for their own clients. They are serving quantum solutions to their clients using Q-Centric. So we have a real example in the quantum finance world of a very big company using quantum to deliver quantum solutions to their clients. So I think that I don't have more time. So I think that this is all because I don't have more time to speak. But your quantum journey starts today. Find me on LinkedIn if you want. I could have a conversation with all of you if you want, and we can talk later if you find this promising or valuable for you. Thank you.
성의 페리스님 강연 잘 들었습니다. 지금부터 질의응답 시간을 갖도록 하겠습니다. 질문 있으신 분들은 손을 들어주시면 마이크를 전달해 드리도록 하겠습니다.
Thank you, Antonio, for the talk. One of the statements that you made caught my attention, which is that you said one of your clients was running jobs on quantum, like 16 different quantum computers in parallel. And it just made me think a little bit about your platform as an orchestrator, right? And if we think about how we execute jobs on quantum computers, potentially in parallel, or leveraging the fact that you have like a network of access to different quantum computers, is that something you've thought about building in, or like using CUDA-Q, right, as a middle layer to deal with that orchestration? And also bringing that back to that context of, for instance, JP Morgan's talk today, where they use like 4 different supercomputers, right? That they had to like link together in some way, orchestrate together to solve that problem. I was just curious how that would be used in your platform, or if that's even a possibility.
Okay, it's a very good question I think. When I spoke about using different quantum computers in parallel, we are building that, but we don't have what we call code one runner everywhere. Okay, this is not how it works. What you can do is, if you have, for example, Qiskit-based algorithm, you can run in different computers that allow Qiskit-based algorithm to run that in that way. But you don't need to change anything in your code. You only need to select your quantum provider. Inside the quantum provider, you need to select the quantum computer. Imagine that you have a provider that have more than 10 computers, and you want to test all of them in parallel. you can do. It's not, I have one in Qiskit, one in Rocket, one in SARQ, and I need to build a code that runs in everywhere. No, it's not that. It's that I use Qiskit capabilities to build my quantum algorithm in Qiskit. If I can translate to Amazon Bracket, could be good, because okay, we can build a quantum circuit using OpenQSN 3 or 2, whatever, and then send to other different SDKs and then run. Okay, but the important thing is, if I want to run in my laptop, I need to code, okay, I want to use, for example, IBM, and then I want to use IBM Sherbrooke, and then I want to use that configuration. But why, if you have a platform, why cannot you send all your workloads to all the computers in parallel and then analyze the result using your own metrics and then say, okay, this is the most promising solution? And that's what we do. In this hub, we have 16 different, but of course there are some of quantum annihilers that building a quantum algorithm using quantum annealer is not compatible with gate-based algorithm, of course, but the use case is exactly the same. So you can compare different algorithms using different quantum hardware from the same use case, and then you select what is the solution that gives you the most promising metrics.
Okay, thank you.